Welcome to VKS Coding. So in this video, we'll talk about all type of databases. So without a delay, let's get started. So first one, we'll start with the SQL database. So first point with the SQL database will be it is having the predefined schema and before storing the value. So it means even if you want to store the employee detail, first we have to define the schema. Like here I have defined ID, name, salary, address and department. Then after that I can store the employee details on the tables. So this is the first point. Second one is the data in a centralized way. So what I meant here is suppose we have an employee table and it is having a primary key that is having a reference for an address table and it is having a reference to the another department table. So all will be stored in a single server. So basically all will be stored in a, so that's why we are referring as a centralized way. Third one is when we talk about scalability, it is easily vertically scalable. And when we want to scale between the multiple servers, so it is very challenging and time consuming as well. That's why it is considered always as a vertical scalable. And it provides a ACID property. So what ACID property means here? Atomic means if we make any transaction on the DB, either it is a successful or it is failure. Either if we abort the transaction, it will be rollback or it will be successful. That is nothing but a atomicity. Second one is the consistency. So what is the consistency? It means if we make any transaction to the DB, it will put the DB into the valid state and there will be no schema violation. What I meant here is suppose we have made a constraint as there will be no negative balance in the customer account. So suppose if somebody is trying to enter as a negative balance, suppose 5 is entered, then this value will be rolled back. So that is nothing but the consistency. What is the third property is isolation. It means transaction can be executed concurrently. It means suppose there is a transaction T1 and this is a transaction T2. Both are happening in the single database. Then it should not interfere with each other. Both will be independently executed successfully. And the fourth property is the durability. Once the transaction completed in the database, that details will be persistent into the database. And even if the failure happens, the data should be persistent in the database. So this is about the ACID property. Now the question arises when to use the SQL database. So here I have mentioned few points where we have to use the SQL database. When we have a structured data and wanted to perform a flexible query onto it, and when we need a asset property and we wanted to work with the consistent data and the data will not be increasing the huge amount and will not needed many servers, then we can go for a SQL database. So few SQL database I have mentioned here is MySQL, Oracle, Postgres, SQLite, MariaDB. These are the categories of the SQL database. Now let's check the another category of the database. So we have another category of database is the NoSQL database. So when we talk about the NoSQL database, it is having a unstructured data. And the second property it is having, we can store the values in the multiple nodes. So suppose we have a employee data, we can store this employee information. Suppose we have a one table and from this table we can store some part of the details from the db1 and some part of the information from this table in db2 and some part of the information from this db in db3. It means we can distribute the data right between the nodes and it is horizontally scalable. So it is having the third property as horizontally scalable. And the fourth property is it provide a base property. So what BA stands for is basically available. It means suppose we have an application and we have a DB1 and DB2 and it when it writes a value a equal to 5 and it query the db2, it should get a equal to 5 from the db2. And how it will happen, because we will make us there will be a syncing mechanism which will sync the data from db1 to db2. So that's why we are saying basically available. It means even the this server will go down, the data will be served from the database too. That is called highly available. even the one server goes down, we can data can be retrieved from the another server. And the second point in the base is the SS stand for safe state. It means the value can be changed even without the user interaction, but the value will be in the safe state. What I meant here is, suppose there will be two DB in sync and it is having the value, first one is having the 4 and initially both having the value 4 and it is having in the sync. And suppose the write comes and it's changed the value 5, then the every time sync happen after 5 seconds, then after second 5 second this db value also a from 4 to 5 it will become, because that's why it is referring to the safe state. And third point is the eventual consistent. It means when you query the data you might get the older data, and because when you sync the data it could take time to sync the data, because syncing happen even 5 second, 1 second, 30 second, however the scheduler was scheduled. And even the application is querying the database one and it is having the latest data, then it can search the latest data. But if the application query the another database which don't have a sync data, then it can get the older data. But eventually after 30 second or 5 second when the sync happen it will get the latest data. So that's why we are saying eventually consistent. Now these are the properties of the database. Now let's see when to use the database. These are the properties. Few points are mentioned when to use the database. When we need a basic query need to be performed and we don't need a acid property, we need a base property, and we wanted to deal with the high volume of data and we need a more servers to store the data, and we need also high availability and high performance with the trade-off of consistency. So we can go with the eventually consistent when it will work with me for a high volume of data. Then we should go for NoSQL databases. So let's see what are the different types of NoSQL databases. So first one will be the key value database. So it will be kind of a big hash table. Key can be any integer or string and value can be a string, JSON or integer, anything. And query can be performed based on keys, and it is very fast on read. So basically when we have a requirement for the read and when we need for caching, we should go for a key value database. And we can use for a key value database as a Redis, WordMote and Dynamo. And the second type of database we have in a NoSQL database is a document database. So basically data is stored in a document. So within a document, it will be stored as a JSON or XML. So it is good for a content management. And suppose it could be the product details. Suppose the ID is one and the type is a shirt, color is a blue. And if you wanted to query based on the type, now you wanted shirt on the from the catalog or you wanted a blue color shirt, so whatever the shirt is having the blue color, the details will be written from the database. So it means we can we can query the document by key as well as value. From both the types we can query the document DB, and it is best suitable for the product catalog management and when we want to query perform query on them. And we have an option for document DB is a CouchDB and the MongoDB. The third type of database we have a columnar database. So it helps to store the data in a column wise. So suppose we have a table, it is having the details about 1, 2, 3 and having some name and the salary. So it will group together one column and it will store. So it will be suitable for analyzing the large data set which can perform a fast read write, and even we can add dynamic columns as well. It means some column will have two properties and some column can have a three property. That is also allowed dynamic schema in the case of columnar database. And we have an option in the columnar database is Cassandra and HBase. Now next database in the NoSQL category is the graph database. So when we wanted to store the data whose relationship are best represented in a graph and wanted to query based on the relationship only and we want a very fast response. So what if, suppose in social media if we know the friend relationship, one friend like Ram is a friend of Shyam and Ram is a friend of Rohan, Rohan is a friend of Peter. So this kind of a relationship if wanted to store, then we can go with the graph database. And if you try to store this kind of information in the relational database, then it so the performance will be very huge difference in the performance. because in the relation database, suppose it is having a primary key and it is referring to another table with the foreign keys, then it will scan all the all the rows to get the details. So that's why the performance wise RDBMS is very low compared to the graph database, and it is well suitable for the social networking informations, and we wanted to give a recommendation search and all those things. So for that, graph database is well suitable. And what are the options we have? A Neo4j infinite graph can be used for a graph database. Now the next category is the search engine database. So basically it provides a text search over the semi-structured or unstructured data. It also provides the fuzzy search, meaning suppose if you are typing not correctly typing spoon, if you typing spoon, then it will also return the result for spoon. So this is not but a kind of a fuzzy search. It is best suitable for a instant autocomplete or for suggestion. So in this we have an option for Elasticsearch, Splunk and the Solar. Next category we have is the time series database. So basically it is optimized for the data entry that need to be strictly ordered by the times, right? Suppose metric kinds of a data which is generated from the sensor or the monitoring system and that you wanted to store it, then the time series data will be best database to store those values because you wanted to query based on the time ranges, right? And what are the options we have? We have an influx database and KDB plus on that we can store the data. And suppose we wanted to store the data large files like audio, video files, disk image, and on that we don't want to query, we wanted to serve those file as it is, but we can chunk those file and we wanted to serve as a chunk wise. In those category we can go for a object store. So for object store in the market we can go for Amazon S3 or Google Cloud Storage. So these are the option available for the object store. Now let's see all the database in a summary and try to understand when to use when. So when we have a structured data and need a ACID property, go for MySQL and Postgres. This is our the SQL database. Now here is the second category of the unstructured data. So when you have a unstructured data and you need a read heavy request we are getting and needed for a caching for fast response, then you should go for a Redis or Voldemort. And then again one more category in the unstructured data is the whenever you have a unstructured data that is increasing in the size of larger data set and needed for the fast query for analytics and different purposes, then you should go for a Cassandra and HBase. And when you have unstructured data but you want to support the different variety of database and data types basically and wanted to perform query on them and needed for the product cataloging and query on them, then we should go for a CouchDB and MongoDB. Basically, these are the document database. And another option we in the unstructured data need to build the relationship between the data and we wanted to query based on those relationships and needed for the storing this social networking information. So we can go for a Neo4j and the infinite graph. Next category we wanted to need for a search capability and need for an instant autocomplete on recommendation, then we can go for a Elasticsearch or Splunk. And when we wanted to store the metric kind of a data and data generated from the monitoring system IoT devices, then we can go for an InfluxDB or KBDB plus. And we wanted to store the audio, video and the larger files, so then we can go for the Amazon S3 and the Google Cloud Storage. So this is all about SQL, NoSQL, time series, search databases and the block storage. Please subscribe my channel to get to know more about the system design topics. So thank you for watching the video.